Korea Aerospace University. It was one of the national university in the past. Now it's the board of trustees, a Korean airline. It's now a private university. We are a very small university with a student of 5,000. And my school is heavily focused on air transport and logistics. And I'm directing Ubiquitous Technology Application Research Center because I was a senior researcher at Cambridge Auto ID Center in the past. Some of you may know, saw my face in the magazine, Auto ID. And then this year, a few months ago, we got funding from government, another funding from government called ICT, UAV, and Logistics Convergence Research Center. It's our government want to focus on convergence research, and we want to find some opportunities in UAV application in logistics area. So I'm hosting the center, yeah. But today I will talk about some of planning experience. And this project is a $10 million project for 3.5 years. And it's now 1.5 years. And when I started this project, government asked me to do some kind of planning. So I did planning for government. So we make a smart material handling machine. As you saw in the picture, there we are making 4 different machines and 2 different software. When we start this project, there was a background. As you know, Korea is very famous for semiconductor, like Samsung and LG, and mobile phone. This kind of material is very small, and so other also electronics component. And so there were increase of high cost light duty cargo, small cargo with expensive price. And when, however, our warehouse was heavily dependent on the manual labor. So 60% of warehouse cost was labor cost. And as you know, picking requires a lot of manual task. So we realized we need a high-speed material handling machine for light duty cargo. And we found maintenance was an issue because at that time we import a lot of machine from outside, and even from Germany we import a lot of machine. It's very good machine, but maintenance cost was too high. One of a big Korean company called Lotte, I think they got sort of from Dematic, and they paid over $7 million for the machine, but they pay $1 million for maintenance every year. So it's quite ridiculous. I mean, the product itself is very good. However, for some case, they have to keep some component part. If the machine is break down, they have to do some action. So the issue was maintenance capability. So we decided to start material handling machine project. So we named ourselves Mark 4.0. The meaning of Mark is we are multiplied team and agile team and creative and high performance team. So we make 4 different machines. So we say, okay, Mark 4.0, and it's speedy. And we believe we try to achieve 4th generation machine, which means I just defined this by myself, so this is maybe not reasonable. The 1st generation maybe tool, right? And 2nd generation maybe standalone machine, automatic machine. And 3rd generation maybe network-enabled machine. And 4th generation, we target 4th generation, the ubiquitous technology-enabled smart machine, which we can operate machine by mobile device. Korea is very strong in ICT technology, so we try to control all the machines by mobile phone and PDA or whatever. So, and we try to have smart feature, and a lot of researchers say machine is smart or their project is smart, and we were thinking about what is smart, and we just term ourselves smart. S stands for safety and security, M for modular, measurable or maintainability, A for agility, R for responsibility, T for track and trace. So all our machine has this kind of features. So we try to contain this kind of concept in the machine. The structure is like this. So our university is the principal investigator. We make a warehouse control system and maintenance cloud software. And we also research algorithm for machine. And there are 4 small, medium-sized company. SMC is a 70 years old machine manufacturing company. Ilyang worked for Hyundai Motors. Jetpack is #1 vendor for Electron. Saltwork is doing some software. Ironically, when I work with this small and medium-sized company, I found they don't think about design. So I contacted German design company called Pilot Fish. They are based in Munich and also Amsterdam. And so they are one of my team. So they design our several machines, and I'm very satisfied with their performance. It's very creative, and we have been with them for 2 years, and very productive. And another team is IMS in USA. IMS is an intelligent maintenance system research center designated by NSF in USA. So they are a group of 5 universities. They research intelligence maintenance. So we make this team, and we have 2 big test beds. StatChipPak is a semiconductor manufacturer. CJGLS is the largest logistics company in Korea. It's a family of Samsung. Yeah. And we have other industrial partners, so all our products will be implemented these industrial partners. Now, I will briefly talk about how we plan, how we identify technologies. We adopt bottom-up strategies. So I think most of you are familiarized with this kind of approach, but for us it was quite challenging because there are a lot of technology there, and which one we have to choose was our task. So first we did a lot of technology analysis and also process analysis. And through process analysis, through industrial visit, we visited over 12 companies for a few months. Also, we did a patent analysis, international and domestic, and also SWOT analysis. Then next step, we find need for research and what was industrial need, and also analysis of existing process equipment by very basic operation level. And we select key technology, and we also, because it was government funding, we had to satisfy policy, so government policy. So we try to find whether it match with government policy or not. Also technology feasibility, whether we can make it, or economic feasibility. Then we design evaluation index. I will show you in a moment. Then we select the technology. So as first step, what we did is we did a technology trend survey with 20 international vendors, the best in the world to top 20. And for domestic, we just choose 5 companies because all our material company is very small. So in terms of turnover, we review technology trend, what kind of product they produce. And we also survey 100 types of material handling machine, what kind of mechanism they have. So then, through our industrial site visit, we did a process analysis, very detailed process analysis for different industries. So some industry has some problem in packaging, some industry has a problem in shipping. So we did all details survey and what kind of function we need. So this is an example of pharmaceutical company we visited. There was issues in box erecting. They didn't have a good box erector, so they just assembled box and stacked it and used it. So space was consumed. So also we did some survey with users and developers. There's a very interesting result. I will show you in a moment. And based on the technology, we work with patent office. So we did a patent analysis by machine and element technology. Also, every company, top 20 companies, patent analysis. Also, we get consultant. Second step, we identify R&D need. What is the key features of this machine? What is the industrial need? What is the inefficient process by industry? So we did this kind of R&D need, like in terms of smart concept. Then we did the technology need by industry, what kind of technology we need, and equipment by process. In some process, what kind of equipment we need to replace manual task. And classification by weight and process area, because we are focusing lightweight cargo. When we define lightweight cargo, we define less than 25 kilograms, which means people can handle the tote. As a third step, we did policy feasibility. So, because government, we have to satisfy government. So for example, whether the technology is within 30 future key areas of R&D strategy defined by our government, or target, for example, whether we can achieve 30% reduction of labor cost, 30% of saving energy, 30% of increase in loading. And in terms of economic feasibility, we focused the domestic market and the international market. And technology feasibility, we filter overlapped project. In Korea, we have so many projects overlapped by different ministry. So there were more than, sometimes 10 projects in the same area. So government does not want to give new project, if it is overlapped. So we collect all the government projects and identify the overlap, and also patent. Technical readiness, whether we can do it by ourselves or whether we need help from foreign partners. So this is Korean, unfortunately. It was images, so it's a kind of the procedure we did. For example, this is Korean, but we identify companies and logistics area, whether we have equipment or not in this area. This is international, Demati or Club, or all the company, what kind of product or technology they have. Next step was candidate filtering. So in here is an evaluation of each candidate. So this is process. Then we identify candidate technology. Then there is a different criteria, whether it is overlap or patent, or whether we have a domestic technology or foreign technology, policy, match, and definition of technology. So in each area we did all of this. Then in the selection, this is storage area. We identified candidate technology, and we filter to this technology. And next one was reflection of future growth or market growth potential. So domestic and international material handling market growth rate. So this is the red one is the market growth rate in each industry and each technology. And also patents. So we track the trend of patents. Then reflection of user community, whether so for supplier and user, we did different view, and we ask the same question to supplier and the user. The supplier is developer, academic or industry developer. We found academic and developer has quite different view from users with the same question. So I will show you some, equipment and equipment functional need. Whether we need this kind of function, maybe some function is too advanced. Even though the idea was so good, maybe industry may not adopt the idea. So that was the procedure. Then market growth patent survey. So this is the example. So we have every area we have a point. So we calculate every point, and so from there we have ranking. So we identify software. Korea is very strong in ICT software, so we give first priority to maintenance software and warehouse control system and hardware, packaging, picking, and this was the procedure. So how many minutes do I have? Okay, I will finish in 2 minutes. Okay, this is the example of how we did domestic lightweight cargo trend. And this is patent research we did in every area. Like so, Japan and the US developed packaging operation software very actively in mid-2000, and we identified all the patent and by component. Hardware, for example, this is the example, what kind of gap we have, what we have to consider. One idea is lightweight cargo has variety. We are targeting home shopping and online shopping. Cyber shopping means customer is very picky. You have to pack different product. So machine should assemble very different product, very flexibly. So we were thinking of a box. We see a lot of potential in the packaging market because of home shopping growth, everybody wants packaging. But every product has different size. So we see a lot of potential in here. So this is an example of software review, how we did software review each functions and for each companies. And this is the by industrial survey. Some of the sequence is not correct, but we check all the steps of logistics and what we need from here. And this is the example of survey for user. When they choose equipment, first priority was performance. It was same as user and the developer. Second priority, user consider maintenance. But developer consider manufacturing cost. They want to make it cheap. But user want cost and price as the third priority, third important. And developer think maintenance is not that important. So they have a little bit different view. This is the structure of the project, and this is an interesting result. When we developed this project, it was very hard to persuade government because I get big fund and government doesn't know how to invest. So what I did is I chopped all the technology, very details, and identified what is already exist in the market and in company. So we found in this software, 18% of technology is already there as an element technology. So we don't want to develop that one. We can use just existing technology. And 10% of technology already there. However, we have to improve it. So we identify, okay, we can focus on 10%. And another 72% we have to do from the scratch. So for all machine and for all technology, we did this. We chop down all the technology, very detailed, and identify whether this is already developed or whether we have this or not. So we assign budget to each new task and develop tasks. So by doing this, we save a lot of money for developing projects. So I could develop 4 different type machine and 2 software with $10 million US. But all other projects in Korea, I should not say all other, but maybe we save half of the budget. So government loved our project. So yeah, it was a very, I think, ideal idea. I mean, and it works very well because we don't know, which one we have to focus. So this is what I have, and I keep the time, right? Thank you.